So the assignment from the last video was to create a small program that does nothing but create a socket and then release the file descriptor. In order to see whether there is already something interesting to see with the ESS tool, the program is supposed to wait before actually closing down the socket. Alright, so let's build our little program that only creates a small socket, and that's mostly it. Okay, so the first thing we need to do is we create a main function, and main typically returns an integer. And you can do with void, and main takes a bunch of arguments, which can be empty, but typically you have the amount of arguments passed as parameters to the call of the function, and then you have the parameters themselves, and the first one is the name of the program, and that is an array. Alright, so we've seen the socket system call, and the assignment basically said we are supposed to open a IPv4 UDP socket. So let's do that. We know that the return value is an integer. And we also now know that the socket system call is accepting 3 arguments. So the first one is the address family, which is, or the domain, it's AF-INET for IPv6. Sorry, for IPv4, of course. And then there is the datagram type we want to use, so a UDP socket. And the protocol parameter is 0 because that is the default. All right. Once we're done with it, so at the end, we have to close that socket again. So let's do that already. Looking good. Now, this will not compile, but we try anyway, just to see what Clang is complaining about. So Clang needs as an input the name of the file you want to compile, and it is complaining about a bunch of things. So it's mostly complaining that there are things that it doesn't know about. In particular, it doesn't know about the socket system call. And we've basically forgotten the includes. So let's look at what socket needs, where the definition of socket is, and that's in, so there's 2 basically. You need to include these 2 here. Let's do that. All right. We probably don't need this. Okay, so let's try again to build it. It doesn't know about close. Then let's see what we need here. Okay. So now that we have that as well, it should actually create a program. Here we go. So the complaints are gone. It can build a program. What we always should do really is tell Clang to warn us about all the little mistakes we made in the program, and is not complaining about little mistakes either. So that is good. The assignment said we should call getChar in the middle, so we can inspect that socket. We don't really need the return value because getChar in this case is only meant to halt the program for a little while. And it's complaining it doesn't know that either. So let's have a look at where that is defined. And with that complaint should be gone, and it is. So the program looks good for the most part, but there are a few things that I really don't like about this program at this point. So every time you call a function, there's a return value, and getchar is different. We're not going to look at the return value. It's irrelevant for us at this point. But the system call socket returns a file descriptor or -1 if it fails. So we really need to actually check whether this function returned a valid file descriptor. If not, there's no point in continuing, and we can exit the program. So we want to know if the returned file descriptor is smaller than 0. And if that is the case, we have an error we call p-error, because the error number is set. So we want to have as much text as we possibly can to see why the error came up. And we can't really recover from this, so we return all right, so this looks much better now, but it probably will complain, and it does because it doesn't really know exit failure, and that comes from exit. Oh, and we don't mean that exit, but we mean the system call. And exit we find in here. So let's see if that complaint is gone. And it is. So that is very important. We always need to make sure that the return values are being checked. Otherwise, we might end up in certain states that are unsafe or might actually crash the program, and that is bad. If something fails, that's fine, but at least you can give a small printout about what happened, so you can actually debug the whole thing. There's one tiny little thing I don't really like, and that is that we don't explicitly return from main. So 0 will be returned here when we fall out of main, but I really like to be explicit about what I return. Okay, and that should compile too. Oh. Good, so this looks good. Now before we continue with actually running the program and using the SS tool to see whether there's something interesting to being looked at already, I really want to create a makefile, because every time I compile the program, I need to get this line back. I'd rather just want to type make, which is much nicer. So let's do that. Let's create a makefile. And a makefile has a very simple syntax. So basically you tell make the name of a target. And the name of the target is basically the output of the line or lines that follow that target. And this output typically has a prerequisite, it has input, and in our case there's a file called 01.c, which is the input to our compiler line. And then the next line is a command. It has to be prefixed with a tab, and here we say clang. We want warnings 01.c, and now we tell it that we want to have a file name as output that is only called 01. So that's our target up there. And now make can have a look at the last modified dates. So if 01.c has been last modified later than the output, which is only 01, the executable program, then it knows it has to recompile the program because the inputs are younger, so to speak, than the output. And when it sees that the output is older than the last modified date of all the inputs, then it basically doesn't need to build it again. We can test this. So let's first save it. And let's call make. That worked. If you call make again, it shouldn't do anything. And it doesn't. It only tells us that 01 is already up to date when we make a small modification to the file. And make doesn't know whether that's a significant modification or not. So this is only an extra line that I added. But make doesn't know that. It doesn't know the semantic of the inputs. It only knows the dates of inputs and outputs. And I changed the last modified date of the input. And we'll create the file again. And now it will tell me it's up to date. Okay, so now that we have everything in place, let's execute the program. Let's call it 01. And let's see if we can see anything. So we talked about the SS tool. And if you look at all the sockets, there's actually quite a bit of sockets that we already have here on this virtual machine. But we only want to look really at UDP sockets. But we don't see any. We created one, and it's still, and we know that, that it's still there because the program is still running. And the program is halting here. So we know that the socket still exists, it's there, but we don't see anything with the CC. And the reason is we haven't used that socket yet, so there's no statistics about it. So the next step is we do obviously more complex programs in the future, but this piece of code right here is a pretty good template for the next step. So there's a socket already in there. We return something sensible, and there's also a bunch of the includes in here that we will be using from this point on. There will be more, but we will from now on, step by step, basically expand on this program. So congratulations, this was your very first socket program, as part of this course.